Hello, my name is Ryan, and today we will be trying to explain how pointers work in C, and I'll do that by going through this very short program and demonstrating how each line interacts with memory, as well as, well, eventually the terminal. So let's begin. The very first thing, before any line runs, we allocate a bunch of memory for the program being run. And memory will then be divided into a stack, which is here, and then a heap. Now, just as a refresher, you can think of memory as an array of bytes, and each of these bytes are going to be given an index. So this would be index 10,000, 10,001, 10,002, 10,003, for example. All these indices have a number. Okay, and that will be very important to remember when we explain pointers. So, first line, integer pointer, my underscore pointer. So this first line, when we see int star, it means my underscore pointer is a variable, and its type is a pointer to an integer. And what a pointer to an integer means, we will eventually get to. Now I will just say, for simplicity, that a pointer is 4 bytes large. This is true on 32-bit machines. They can also be 8 bytes on other 64-bit machines, but for simplicity, we will say that pointers are 4 bytes. So we're saying we're sort of clustering off this portion of the stack for my pointer. That's what that line does. The next line looks like this. My pointer equals malloc 2 times size of int. It looks like an assignment, which means that we're going to try and fill this section of memory represented by my underscore pointer with whatever this function returns. Now, what does it return? Well, what malloc does is first it sequesters off some number of bytes in the heap, and that number is indicated by the parameter here. So 2 times the size of an integer, which is typically 4, that will give you a value of 8. So 8 bytes get sequestered off. 1, 2, 3, 4, 5, 6, 7, 8, like that. So these get malloced. And then I said that addresses have indices. Well, addresses are just numbers. So let's say that this address is 30,000. That is the beginning of the sequestered off chunk. That's what malloc returns. So this just becomes my pointer is equal to 30,000, right? And it's just like any normal assignment. We fill the value, we fill the chunk of memory represented by my pointer with the value returned by malloc. And you can think of this graphically as sort of an arrow pointing to this address. And that'll be pretty useful for understanding this line, which is basically, in English, saying dereference my pointer, and then store 42 into whatever dereference means. So what do we mean by dereference? Well, wherever you see this star, except for when we're declaring a pointer type, which you can tell by seeing if there's a type next to it, like integer, next to the star. If there's none of that, we are dereferencing, which means follow the arrow, basically, that's all. And then take the chunk of memory whose size is equivalent to the size of the type being pointed to. So the type is an integer. We are pointing to an integer, is basically what we're assuming. And an integer is 4 bytes. So that's sort of what this means. Dereference means follow the arrow and consider a chunk of memory equivalent to the size of that data type. So what do we do here? 42 is being assigned to this chunk of memory being pointed to. It is literally just an assignment. That's all it does. So yeah. Okay, what's next? Star minus your pointer plus 1 equals 29. It's very similar to this one, except we have this addition here. So what's happening here? We did say addresses were just numbers, so it makes sense that math works on them, but the math is a little funky. You might think it would be 30,001, but in fact, the my pointer plus 1 becomes 30,004. Why? Well, basically, when we're doing additions to pointers, we first multiply the constant value by the type being pointed to. So this would be 1 times the size of an integer, which is 1 times 4. 30,000 plus 1 times 4 is 30,004. And we can see in memory, if this is address 30,000, This will be address 30,001, 30,002, 30,003, 30,004 is right here. And the reason this is useful, as you can see, is we just skipped the chunk of memory that was used to hold the value 42. And this is why we do this multiplication of the type size before we do the addition. So the arrow is not as helpful here anymore because there's no arrow pointing to 3004, but just numerically, this is what it means. The address at 30,004, take that chunk of memory and do whatever you will with it. In this case, it's an assignment. So you assign the value of 29, 2, 3, 1, 2, 3, 4, into this piece of memory. Okay, the rest should be fairly straightforward once you understand that this dereference means follow the arrow, or take the number, look at the address, and use its value. So here, star minus her pointer is the right-hand side. So what we do is minus her pointer is 30,000. We look inside address 30,000 to take its value and replace this with 42. That's what it resolves to. So stored value takes on the value 42. This is a variable declaration, so we are again telling the compiler when we allocate stack memory, sequester off however much memory you need for an integer, and in this case, immediately assign it with the value you get here. And finally, function calls kind of work the same way when you have a dereference in here. It's just follow the arrow, or in this case, you can't because this resolves to 30,004, which doesn't have an arrow. We can still look at the address in memory, 30,004. Remember, my pointer is 30,000, plus 1 times 4 is 30,004. I get the value in here, it comes 29. Stored val, you remember, is 42. And then we just print. So the terminal gets the value 42, 29. And I hope that was that demonstration showed you how pointers worked.